Legacy students, Marsh here. So today we're going to talk about counters and logical operators. So let's jump on it. So counter variables, stuff that you want to know about counter variables. Well, a counter is just a variable that's storing a number that's incremented by a constant value. Counters are very useful for keeping track of a number of times the user clicks a button, enters a guess, types a password, anything along those lines. When I'm updating a counter, it's going to take the form of the following. The counter's name equals the counter's name plus the constant. So counter is just the numeric variable, and the constant is the number that we're adding. So let's say my counter variable was named clicks. Okay? I could say clicks equals clicks plus 1. That would be my updating of my counter, the variable clicks. I'd be adding 1 to the variable and then putting it back inside the variable. A counter should be initialized when it's declared and then be updated by an unchanging amount. So maybe it starts at 0, maybe it starts at 1, depending on what you want to start it at. But it should always be given a value that makes sense when you create it for the first time. The other thing we want to talk about today is logical operators. So we can actually take these Boolean expressions that we've been building and we can form larger ones with logical operators with ands and ors. A logical operator joins two expressions to create an expression that's going to either evaluate to true or false. So that's basically me taking two pieces of an if statement and slapping an and or in the middle. There's also a third logical operator that is not changing an expression from true to false or false to true. So basically it just kind of flips the statement for us. And versus or. So when's the difference? Because a lot of times in English we don't exactly use them correctly as in computer science. So and is going to require for both expressions that you are joining to be true. And here's an English version of that. So if it's sunny outside and you don't have class, then you can go to the beach. So both things have to be true for me to be able to go to the beach. It has to be sunny, and I cannot have class. If I have either of those as a false statement, I cannot go to the beach. Then there's or. Or requires either of the expressions to be joining for it to be true. So here's an English version of that. I buy shoes that are comfortable or cheap. So here's the thing with these shoes. I will buy them if they're comfortable. I will buy them if they're cheap. And I will buy them if they're comfortable and cheap. But if they're not comfortable and not cheap, I will not buy the shoes. Okay? So either of them have to be true or they both have to be true for an or to be truth. Now, these are kind of confusing as we're building them. So what a lot of computer scientists will do is what's known as a truth table. A truth table helps us figure out if a logical operator is what will be displayed based on information. And these are sometimes the easiest way to decide what will be displayed. So for an and, let's say for the first expression, I have a true statement, okay? And let's say the second expression, I also have a true statement. And if I put an and in the middle, so if I have a true and a true, since both of them are true, that means it is sunny and I do not have class. The and would result in also a true, since both of them are true. Let's say the opposite is happening. So let's say I have a true for expression 1, but expression 2, I have false. So let's say it's sunny outside, but you know what? I have class. So the answer, if I put those two together with an and, I would say it is false. I cannot go to the beach because one of them was not a true statement. Let's say if we flip that around, let's say expression 1 was false and expression 2 was true. Well, since again, only one of the expressions is true, and if I combine those with an and, I would have a result of false. Both have to be true in an and for me to be able to say true. Now, last thing that could possibly happen in our possibilities is, what if both expressions are false? Well, the and would then be false, right? So this would be, it's not sunny and I have class, so I definitely cannot go to the beach, okay? So notice on an and, it is very, very hard to get a true on there. So keeping that in mind, when we're writing these programs, an and statement is going to make a true very difficult to accomplish. Let's take a look at an or using the same kind of idea. So let's say expression 1 is true, and let's say expression 2 is also true. It would be the example of the shoes are comfortable and they are cheap. Both of them are true. So since I would connect that with an or, that would also still be true. You're still going to buy the shoes, right? Well, let's say one of them is true and one of them is false. And I put an or in the middle. Well, in the or statement, only one of the expressions has to be true for the full thing to be true. So this would mean that the shoes are comfortable, but they're not cheap. I'm still going to buy them since they're comfortable. Now, what if we flip that around? So they're not comfortable, but you know what? Those shoes are cheap. Since that's the case, one of them is still true, so we still are going to get a true statement if I connect it with an or. So keep that in mind as you're completing these. What about the last one? What if it's a false and a false? So that is, they're not comfortable, they're not cheap, we definitely ain't buying those shoes. So that would be a false. So notice with an or, it is super easy to get a true. So it's more common for a true statement to happen if you have an or than a false to happen. Last one is a not, and he's kind of special in the regards of he only works on one expression. So if I not a true, it would just be false, right? You're just flipping the statement. If I not a false, we will get a true. So think that through as we're completing these in the regards of you're just flipping the statement around. So let's evaluate some Boolean expressions together. What if num1 is 1 and num2 is 9? So num1 is 1, num2 is 9. So let's check. Is 1 less than 2? True, right? So I'm going to put a T there. Is 9 greater than 12? Nope, that's false. So now they're connected with an and. Since it's true and false, that would be false, right? So that's not true. So let's check the next one. Is 1 greater than 5? No, that's false, right? Is 9 less than 10? Yep, that's true. So now they're connected with an and again. So false and true. Well, that entire thing would be false, right? They have to be both true in an and for this to be happening. Let's check the next one. Oop, I got a not on this, so it's going to be a little different. So I got 1 is less than 6. That would be true, but since it's a not, this would be a false statement, right? And is 9 greater than 8? Yes, that would be true. Now I have false or true. Since it's an or and one of them is true, we would display case 3. Okay? Let's try the next example here. Okay, num1 is 1 again, and num2 is 15. So is 1 less than 2? And is 15 greater than 2? So 1 less than true? Yep. Is 15 greater than 12? Yep. True and true. Since they're both true, I would say the answer is case 1. That one was fast, since that one was a true statement right away. Let's try the next one, the last one for today. Num1 is 9, num2 is 9. So, is 9 less than 2? False, right? Is 9 greater than 12? False. False and false? Definitely false, right? Let's check the next one. Is 9 greater than 5? True. Is 9 less than 10? True. True and true gives us true. So I will get case 2. And that's the end of the video. We will keep working on these ands and ors on our information so that we can continue working on them, because they are a little confusing as we're building them, and especially now as we start to put them into our programs. But until then, I will see you later, Sabers.